So we're here for a double talk through of Double Yajilin. We'll start with this puzzle from John. After doing some easy things with the 0 clues, really this puzzle starts from looking at the 2 clues that involve 3s. I like to use this notation, at least in typical Yajilin, for when I know at least one of these 2 cells will be shaded. In a puzzle like this, we actually end up having to still shade some more because we're shading dominoes. But sort of starting from this path and then completing out the dominoes once we know where they must be. So we get some symmetric progress in these spots. We don't immediately know if this domino goes left or right, but having this kind of notation, what we get is the fact that if this domino came to the right, it's going to force this shading to be like this, and we'll isolate a cell. And that sense of crosstalk is why it's helpful to just sort of know where collisions will happen. In this puzzle, this has to come to the left. We get this because we have to wrap around the shaded cells with loop cells. We isolate a cell here, so that's going to need to be shaded as well as the one adjacent to it. Now we can start to do similar thinking here. We now have made the cell have just 2 exits, but we know that it can't use both of these for the loop, so the question is, can this be an unshaded cell? Well, this being shaded, that would never work. So this has to be shaded. Just like this cell couldn't come to the right, this one up here can't come to the right. It's going to isolate space down there, so we can finish out this domino pretty easily. Now we've actually marked as unused the cells above and below the cell, so whatever way this domino goes, it's going to be forced to use this cell that I just marked. We should now recognize that in this lower right corner, we have an even number of ends, which means we're not going to have a new end come across. That would be 1, 2, 3, 4, 5, 6, 7. We couldn't close a loop if it came across, so we have to shut off this gap to have everything work out. We're now in a place where, and this is a kind of harder step to see. It sort of comes from checkerboard thinking in some ways. Right now we have a space like this which has an even number of shaded and unshaded groups. If we're just looking in this box, if we shaded more cells in the space, for instance, if we shaded this down, in order for this to still have a loop, we would need to shade one of these, what I've marked, I guess, diagonally cells. And we just can't do that. And so it's not often the case that you can see these logically, but this is maybe a situation, this is one of the harder deductions in Yajilin or Double Yajilin in general, is where shading in a certain direction will make a space that you just can't complete for parity reasons. So the logical deduction that comes from the fact we can't shade one of these crosshatch cells is like, and in this drawing of the loop, we've left one of those unused. All of this is a very long way to say that by either trial or by parity, you can recognize that this domino has to come up. Once we mark that in, we now have to fulfill this clue, which actually is going to place a domino in the bottom. It would first be marked like this in my system, but I know that this second cell, the lower cell, has to be used. So I get this. Of these choices, the only one that still works is to shade above. Or we close that out this way. This 2 up now needs to be used, and so it's going to need to have, as we saw earlier in the grid, 2 cells like this. The 2 to the left now can be used. Completes out this space. This comes over. This has to come out. It doesn't want to close over itself. You'll see that in this area we now have 4 ends. So this end can't really come to the right. That would isolate an odd number of ends in the space. So it comes to the left. These ends don't want to connect, so this comes up like this. The last clue is really using this one up in combination with the fact this cell has to be shaded because the loop can no longer get into it. That opens up the rest and we finish this puzzle. Hopefully it shows a little bit about both the way to use notation in double Yajilin puzzles, how Yajilin clues can push each other, particularly like how these cells couldn't come over here because they would isolate the grid, and then even a very harder deduction with kind of parity in this corner with a cell that can't be shaded because it's going to make an odd number of remaining cells used by the loop. You always need an even number of cells used by the loop in any area. So that gives us a harder example from Prasanna. It actually has a clever theme, one that I've seen a few times in classic Yajilin puzzles, but I've never seen in this double Yajilin variant until this occasion, which is one that just has all these outside clues. That means the effects are going to be much more indirect than usual. We're not going to just be having a clue near an edge that points at just a few cells and makes it easier to place. We're going to be pointing at as many as 10 cells. And so really the only way to start is to mark off these zeros, recognize corners we have to use. Here's a corner with one unused cell, so it can't be shaded because this is a domino variation, but everywhere else in the grid these two could be shaded. We could get dominoes in here. You really have to use some of the bigger clues to make progress. The 4 downs currently has 5 locations or 5 potential domino placements, so it's not a great place to start. The only place it looks great to start is this 3 to the right. You can do this notation like so. There's a rule that's actually quite helpful in classic Yajilin, which comes up in this puzzle as well. It's really true for double Yajilin, which is when you're one off of a border, so this second row is one off of this border row, you can't get a situation where you're shading cells that have just a single space between them. And the reason you can't is because you end up making these things that all called T-junctions, sort of 3-way junctions. If you think about this, you can make the loop come into this cell, you can make the loop come out from the cell. Let's imagine this is how the dominoes look. You can't get back into this space and get a single loop to form. So the way this manifests in classic Yajilin is often when you're just one off an edge, you have to leave 2 white spaces between any shaded spaces. So in this situation where we have to shade 2 cells in this region, 4 cells, we have to shade a cell, leave 2 white spaces, shade a cell. This even continues over to the left where we again need to leave 2 white spaces and shade a cell. So imagine we didn't do that, imagine we shaded this cell, then we've made another T-junction right up here. And that should be pretty clear that it's just not going to make a functional loop for you. So with this as the initial way that we know that the 3 dominoes are placed in this grid, for that row, you'll see that they all end up having to point downwards. Let's mark a little more that we know. We've actually marked everything in this row. We have this coming down. We've marked everything in this row actually, so once we get this cornering in, get that cornering, we get to here. Now the 2 across clue is quite limited. It actually is going to place 1 domino exactly there, and then 1 that has to be here and coming downwards. We have an isolated rectangle up here with 4 ends in it, so we can't cross this boundary. We need to have those come together. The next place I think it's productive to look, well, I think there are actually two spots. First, this 4 down, got 1, 2, 3 dominoes. This is the 4th. Its last used cell is going to have to be the lower right corner, otherwise there's no way to come in and back out from that corner. Another place are these 2 columns. Right now we need 1 more domino in column 3 than in column 4, and it can't be horizontal and connecting column 2, so we're going to need 1 more vertical domino as a deduction here. The only places for such a vertical domino are in rows 6, 7 or 7, 8. Those share the fact the cell is going to be shaded, and we're going to have vertical domino. The last domino then is going to want to sit in both of these columns and be horizontal. The only place that can sit without touching another domino is down here. So we get this pretty cleanly set in the grid. Let's now look and see that this 3 across in row 8 has 1, 2, 3 places for it to sit. Can look back at column 1, which has a 1 down. It's going to need a vertical domino that uses one of these cells. Notice that if the loop comes to the left, it's going to get stranded, so it's going to actually use the bottom here. Get that marked. Now let's come back over here and think about where the domino cells can be used here. First, recognize that if we don't shade this corner cell, particularly where we have 2 dominoes that are just next to each other, we're going to get to a situation where the dominoes have to come opposite, which is going to be quite cramped. It's actually going to force a domino to come to the right here because it can't come up. It's going to isolate the loop. So it should be pretty obvious from the start that when you have 2 clues that are right next to each other, it's almost always the case, not exclusively, but almost always the case that they'll actually be pointing to where a domino is used. So it's good to consider the alternative and show it's logically impossible. We now get to a place where this cell is somewhat isolated, and in particular, if we shade it over here, we would get a place the loop just can't go. So this cell is not shadable. The remaining cell for this larger domino is over here. Get sort of these things marked. We do still have to figure out if this domino comes to the left or comes up. And here, like some of the deductions that might help are to really consider, I think, this 2 clue and its impact when there's only 1 more domino to place in this space. If we ended up shading this cell, the loop is going to come across, and the consequence is going to place another domino that has to be vertical and add 2 more into this row. A different way to see that, I think, is that you can probably convince yourself that this cell can't be shaded. If it were shaded, it's going to have to be part of the domino above, and that's going to force this, which now isolates the grid. So in either scenario, you get something like this is a shaded cell, unshaded cell. This is part of the loop. Get this kind of closure. See that once this is potentially used, it's going to cause issues with another domino. So instead, this is also unshaded. Now we have down here something like this. This comes over. This comes down. We have now just a closed loop in this corner. It's going to have to come out and extend, and we're through with this challenging puzzle. It really starts by a trick that's in classic Yajilin, which is a sense off of an edge. When this whole space is unused, we need to still at least leave 2 white spaces between shaded cells, or we form T-junctions. Once you're able to see that rule, it comes from working down into these first 4 rows and then thinking about these columns, using the long direction clues to get some spacing that leaves just this far section on the right side to be challenging. And there are a few different options to find how the path goes, but it's really finding a way that you get enough dominoes in, but not too many in this row to get the loop around here and not cause conflicts where this 4 down needs to have a very careful placement of its clues. So hope you learned something in general about Double Yajilin. Obviously these puzzles are a little bit of outliers, but we have the Art of Puzzles 2 book, which has 25 Double Yajilin and 25 regular Yajilin, is a great set of challenges for you. And if you haven't seen it, hope you pick it up. Otherwise, we'll see you again soon.